Today we'll see the sinusoidal source voltage. When the sinusoidal source voltage is applied to the series RL circuit, what is the response? That is current response that we'll see through the problem. So this problem statement, if you see in the circuit shown in figure, determine the complete solution for the current when the switch S is closed at t is equal to 0. Applied voltage is V of t is equal to 100 cos 10 power 3 into t plus pi by 2. Resistance R is equal to 20 ohms and inductance L is equal to 0.1 Henry. So like we have seen in the previous derivation for the same circuit diagram with R and L, what we have to do as a first step, apply KVL. If you apply KVL, 20 into I plus L into di by dt, 0.1 into di by dt is equal to source voltage, that is 100 into cos 10 power 3 into t plus pi by 2. By dividing on both sides with 0.1, you will get di by dt plus 20 by 0.1 is nothing but 200 into I, 100 by 0.1 is nothing but 1000 cos 10 power 3 is nothing but 1000 t plus pi by 2. So characteristic equation, by assuming d is equal to d by dt, d plus 200 of I is equal to 1000 cos 1000 t plus pi by 2. So this will have both complementary and particular solution. What is the complementary function? IC is equal to C into e power minus pt. P is nothing but coefficient of I, C into e power minus 200 into t. By assuming the particular integral as ip is equal to a cos omega t plus theta plus b sin omega t plus theta, we'll find out the complete solution. By assuming this, we'll find out the complete solution. So already we have seen the derivation. Out of the derivation, we got ip is equal to v by under root of r square plus omega l square into cos of omega t plus theta minus tan inverse of omega l by r is the particular integral solution. This already we have seen in the previous derivation. So I'll substitute all these values in this equation from this circuit diagram. What is V, what is R, what is L, those values I'll substitute here in this equation. What is omega? Omega is equal to 10 power 3 into t. That is nothing but omega is equal to 1000 radians per second. V is equal to 100 volts. R is equal to 20 ohms. L is equal to 0.1 Henry. Theta is equal to pi by 2. By substituting all these values in this IP, I'll get IP is equal to 100 by under root of 20 square plus 1000 into 0.1 because omega into L. 1000 into 0.1 square cos of 1000 t plus pi by 2 minus tan inverse of omega L by R. Omega is equal to 1000 into 0.1 by R, 20. By simplifying that, I'll get 100 by 101.9. Square root of this one will get 101.9 cos of 1000 t plus pi by 2 minus 78.6 degrees. So by simplifying further, IP I'll get it as 0.98 cos of 1000 t plus pi by 2 minus 78.6. What is the complete solution? Now I got the particular solution, I got the complementary solution. By substituting that in the complete solution, I is equal to IC plus IP, that is complementary plus particular. Complementary is nothing but C into e power minus 200 into t plus particular is 0.98 cos of 1000 t plus pi by 2 minus 78.6. So by using the initial conditions, when the switch is closed at t is equal to 0, earlier when at t is equal to 0 minus the switch is open. When the switch is open, the current is 0 because this is open circuit, the current is 0. The inductor does not allow the sudden change in current. Earlier 0 current was there. At t is equal to 0 minus means at t is equal to 0 also the same 0 current will carry by the inductor. So that initial condition I'll use here in the complete solution. At t is equal to 0, the current flowing through the circuit is 0 because at 0 minus also the same 0 current is there. So by substituting that I of 0 is equal to 0 C into e power minus 200 into 0. T I am substituting 0 plus 0.98 into cos of, in this equation, 1000 into t is equal to 0 plus pi by 2 minus 78.6. Out of this, by simplifying this, you'll get C is equal to minus 0.98 cos of pi by 2 minus 78.6. By substituting this C value in this complete solution I equation, I'll get I as I is equal to minus 0.98 cos of pi by 2 minus 78.6 into e power minus 200 into t plus 0.98, the remaining term 0.98 cos of 1000 t plus pi by 2 minus 78.6. This is all about the problem. Thank you all.